Good evening, everyone. Welcome to the seventh and second last tutorial of this course. So I will be solving assignment 7 from last year's course, and if you have any doubts regarding the videos or during the problem solving session, if you have any doubts, you can just unmute and ask or write in the comment section. I am sharing the screen. So I have shared the screen. I have shared the screen. If it is not visible, please let me know. So the first question is, find the area of the lower portion cut from the sphere x square plus y square plus z square equals to 2 by the cone z equals to root under x square plus y square. And I will ask you to solve these problems parallelly because these are a little bit lengthy problems. So if you don't solve it parallelly, it will be harder to follow. Okay, so let's draw the region of which we are asked to find out the area. So this is the sphere of radius root 2. So this is the sphere whose equation is x square plus y square plus z square equals to 2. Okay, so radius is root 2, and so now I am drawing this cone. So it is z square equals to x. Someone is asking, good evening sir, 6th week first question, limits explain. Okay, so I will explain it after this 10 problems of this week, because I need to check what was the question. So the equation of this cone is z square equals to x square plus y square. So which means, like, so x square plus y square will be the radius of this cone. So x square plus y square, for example, if it is the radius of this cone, it is r square, radius square. So then as we are moving, up, so how it will look like? So as we are moving up, so this is z, this is z square. So as z increases, that means as we are moving up, this radius will be increasing. So it will look like this. So this is how it will look like. Write it as it is written in the equations. It will be r. If I define this radius, this r as a radius of this, so if let me define it by rho. So it is rho is defined as the distance from here to here, from z to, if you draw perpendicular from z, so it will the distance from the point on the cone to z axis. So it is cutting the, let's say it is cutting the sphere in this circle. So why it will cut? When these two equations will agree with each other. So that means when, so this is the equation z equals to, sorry, this is x square plus y square. So this equation of this cone is z equals to x square plus y square, and this circle is x square plus y square plus z square. So when they will touch, then these two equations will agree. That means when they will touch, then z will be x square plus y square. Z square will be x square plus y square. So then z square will be x square plus y square. So if I put the equation of this cone in equation of this sphere, then it will be, so x square plus y square. So this is the z square, and now the cone also satisfies this touching point. So then it will be x square plus y square. So that means x square plus y square equals to 1, which gives, so this is a equation of a sphere, this is equation of a circle. This is equation of a circle of radius 1. So this will be x square plus y square equals to 1. Okay. So basically you are asked to find out the area of this part of this sphere, area of this part. So I think the region is understandable. If not, then let me know. Okay, so then how we will find that? So let me draw it again. Now it's very simple. Let's say this is the cutting point of x square plus y square equals to 1. This is where in this curve the cone cuts the sphere. Okay, so we have to do surface integral throughout this lower region of the sphere. Now let's define, this is the radius of the sphere. So this is r. Okay, and this r will be root 2, because the equation of the sphere is x square plus y square plus z square equal to root 2 square, that is 2. And let me define the theta angle as this angle and the phi angle as, so if I draw perpendicular this xy plane, so then the phi angle will be, this will be the phi angle. This is the theta angle. So now a small surface element on the sphere, how it will look like? So it will be given by, okay, let me just show you how to calculate that. So for example, assume a small surface element here on the sphere. So now how the surface element will be formed, like at constant r, if you move by theta, so this is the theta, so if you move by theta at this r, so it will cover a length of, so this will be r d theta. So if you move d theta amount angle, so here it will cover a length of r d theta. And if we move along phi angle, so then it will move along this radius, so phi will be moving along this radius. So this radius is nothing but r, it's not visible, this radius is nothing but r sine theta. Okay, so that means this length, it will be, so the angular movement is d phi. If the phi angle moves by d phi, so then the length will be r sine theta d phi. Okay, so the surface element here ds, it will be r d theta times r sine theta d phi. So this is the surface element on a sphere. So it will be r square sine theta d theta d phi, and this r square is, this r is constant, which is the radius of this sphere. So okay, so up to this is fine. And now where we want to integrate, so we want to, so this is a small surface element. So now we will, if we add them up, that means if we integrate over theta and phi, so then we will get the total surface area. Okay, so the total surface area is, will be, to integrate them up, this ds. Okay, so it will be r square sine theta d theta d phi. Now we don't want to integrate all over the sphere, so we are asked to find out the area which is the lower portion cut of this sphere by the cone. So that means we have to integrate in this region. So depending on our integration region, we need to fix the integration limit. So let's look at how the limit will look like. So this is the sphere and this is the cut where the cone cuts. So this will be x square plus y square equals to 1. Okay, this radius, this is root 2, right, and this angle theta for this point, it will be, so this is 1, so this is 1. Okay, this is 1, right. So if this is root 2 and this is 1, so then this length is also 1. So why this upper length is 1? It's because it's a radius of this this x square plus y square equals to 1 circle, and this, why this is root 2? This is because it is the radius of the sphere, that is root 2, and as a result, so this is 90 degree, and as a result this should also be 1. And what will be the theta then for this point? It will be 45 degree. Okay, 45 degree or pi by 4. So we need to integrate from this angle. So phi should be moving from this angle to pi. Okay, so phi should be moving from pi by 4 to pi, and so it will cover then this region. Then if phi moves from pi by 4 to pi, then it will cover this region, pi by 4 to pi, sorry, theta will move. Okay, so this is the theta angle, and now if I move it, so now if I move the phi angle, so while we are moving along theta from pi by 4 to pi, now if I move along phi direction by 0 to 2 pi, so then it will cover the entire lower region. So phi will be from 0 to 2. Okay, so r square is 2, and put it outside, then phi equals to 0 to 2 pi. So there is no phi dependence here, so I can do the phi integration separately, and theta will be pi by 4 to pi sine theta d theta. So this will be 2 pi, this integration will be 2 pi, so it will be 4 pi, this integration will be minus of cos theta, and the limit will be theta will be pi from pi by 4 to pi. So then it will be 4 pi, cos of pi is minus 1, so it will be plus 1, there is minus sign already there, and there will be there is a minus sign, and there will be a minus of this because of we are putting a lower limit, so it will be plus, and cos of pi by 4, cos of pi by 4 is 1 by root 2. Okay, so now if I multiply, so it will be how the options are there. So if I multiply by 2, then it will be 2 pi 2 4 sorry, multiply by 2, it will be 2 plus root 2. Okay, so this will be the area of this lower part. So it will be okay, if I multiply by 4, then it will be multiply by 4, then it will be 4 plus 2 root 2, and this option is the correct one, 4 plus 2 root 2 times 5. Okay, there are also other ways to do it. For example, another way to do it is, so here what we are doing is we are integrating on the sphere. Okay, now if someone doesn't want to do the integration on the sphere, so let's say someone wants to do the integration on the plane, for example, these kind of processes are discussed in the lecture videos. So for example, someone wants to don't want to do the integration in this carved plane, so they want to do it in a this xy plane, for example, they don't want to do in the curved surface. So in that case, how do, so this method will be helpful if we have some complicated surface instead of a sphere, which we can easily do this change of coordinate and just integrate. So how we can do that? So so the total area is, if this is radius is r, so radius of sphere is r, the total area of sphere will be 4 pi r square, total area. And now if one finds out the area of this part, okay, then you can just so let me call it this s1, so you can just subtract this from the total area and get the area of this lower part. Okay, and how to do that? So there is always this way available, like if you want, if you can integrate from theta equals to 0 to pi by 4 and keep the rest, so then you will be getting the area of this upper part. But another way, if one wants to integrate, if one doesn't want to integrate in this carved surface, if one wants to integrate in the xy plane, so that then, for example, if one wants to integrate in the xy plane, so in that case, how the integration will transform? So let me put it for S1. So first we are calculating this S1, this area of this upper surface. So it will be, so let's say this area element in this xy plane, this is given by dA. Okay. So in that case, how dA will be connected to this area element on the curved surface? Let's say this is a small area element in the curved surface. We call it ds1, for example. So how they will be connected? So ds1 will be root under del z del x whole square plus del z del y whole square plus 1 times dA. This method is already discussed in the class. So one can use this method to so to get the area of this upper part. Okay. So how this will be done? Like, so Z is on the sphere. Okay. So if one so this dA will be, okay, let me just do it. So Z is root under 2 minus x square minus y square. Okay. So then del z del x will be half times minus of 2x by root under 2 minus x square minus y square, and del z del y will be half minus 2y root under 2 minus x square minus y square. Okay. So now if I put this del z del x and del z del y, so to ds1 will be root under this 2 cancels. So then del z del x square mod square will be x square by 2 minus x square minus y square plus del z del y mod square will be y square divided by 2 minus x square minus y square plus 1 times dA. So dA is the surface element in this xy plane. Okay. So in the xy coordinate, if I took the xy coordinate, Cartesian coordinate, then it will be dx dy. So it will be root under, so if I do the addition, then it will be 2 by 2 minus x square minus y square times dA. So then the total S1 will be integration of ds1, which will be integration double surface integration of this term, root under 2 by 2 minus x square minus y square times dA, and this dA in this Cartesian coordinate in that plane, it will be dx dy. So here this integration, so this will be the, if one integrates this term in this xy plane, then he will basically get the area of S1 in this curved surface. So now you can easily parameterize this. So instead of as there is x square and x square minus y square, so that means as this term you can write it as 2 minus x square plus y square. So in that case, we can, as there is x square plus y square, we can transfer our coordinate from xy coordinate, that is Cartesian coordinate, to plane polar coordinate. So in that case, so if I consider this distance as rho and this angle as, for example, psi, let's say. So in that case, this dA will be in that coordinate. This dA will be, instead of dx dy, it will be r dr, sorry, rho d rho, rho d rho d psi. Okay, so it will be double integral of root under 2 by 2 minus rho square rho d rho d psi, and rho will be going from, so we want to calculate this region, so rho will be going from 0 to 1. Okay, so this is x square plus y square equals to 1. So up rho will go from 0 to 1 up to this projection. So rho will be going from 0 to 1 and psi will be going from 0 to 2 pi. And this integration is quite easy. So if I take the root 2 outside, and this 2 pi psi integration I can do separately because there is no psi dependence here, so it will be 2 pi. And this rho integration 0 to 1, so it will be 2 minus rho square whole to the power half minus half, and this rho d rho I can write it as d of minus rho square by 2, so it will give me basically rho d rho. Okay, sorry, there is a minus half. So this minus half times rho d rho square, it will give me rho d rho, and so if I take this minus half outside, it will be minus root 2 pi 0 to 1 2 minus rho square to the power minus half, and this d of minus rho square I can also write it as 2 minus rho square. So this is basically kind of an p term, and this is dp term also. So I can now integrate it in the usual way, that is 2 minus rho square whole to the power minus half plus 1 by minus half plus 1. This rho will be going from 0 to 1. So minus half plus 1 is half, so there will again be 2, so it minus 2 root 2 pi, and it will be, if I put the upper limit, so then it will be 2 it will be 2 to the power half minus, if I put the lower limit, it will be, sorry, if I put the upper limit 1, then it will be 1 minus, if I put the lower limit 0, that means it will be root 2. So then it will be minus pi times 2 root 2 minus 4. Okay, this is the S1, and now what will be the total area of this sphere, entire sphere? The r is, our r is root 2, so r square is 2, that means it will be 8 pi. So the area of this lower portion will be S equals to 8 pi minus S1, which is 8 pi plus pi times 2 root 2 minus 4, which is if I take pi outside, so it will be 4 plus 2 root 2. So this will be the area of this region, this one, under the point where this cone cuts. Okay, so there are two ways here you can integrate. You can either integrate throughout the sphere, or you can integrate on a plane. So how that projection can be done, so that is given by this equation. Okay, so this ds1 is the area element on this carved surface, and if we want to project it in the uh, it in the plane, so then the plane area element is dA, then it should be multiplied by this term. Okay, this is very easy. Like, we are asked to find out the surface area of a sphere of radius 2. For z greater than 0, that means it will be a upper part of the sphere, okay, the upper hemisphere. Z y this radius is 2, and we are asked to find out the area of this surface. So easily one can find out that area is total area will be 4 pi, r square is 4, so 4 pi 4, then the half will be by 2, so 8 pi. This is the easiest way. But if if one doesn't want to integrate, so this integration is done. So this integration is done uh, by taking the surface element like ds on the sphere, that will be like r square sine theta d theta d phi. And if you want to integrate this whole thing by putting the proper limits, then you will get this surface area. But so this integration is done on this curved surface. But if one doesn't want to do integration on this curved surface, if one wants to do an integration in this plane, so then how this integration will transform? So that, let me do that also, because that is what we are taught in the class, so we should do some application of that. Okay, but if this comes in the exam, you just do it in this way, write it by, it's fine. So okay, so then z equals to 4 minus x square minus y square, root under of that, right? So now consider a surface element in the xy plane, that is dx dy, and consider a surface element, let me call it dA, and let me call this ds. So this will be the surface element corresponds to this. So ds will be the surface element on the curved surface, correspond to this dA surface element in the plane, in the xy plane. So how they are connected? Obviously they are not equal. So how they are connected? That is given by, like, ds will be del z del x. So this is dA. So how they are connected? The multiplication factor is this one, plus del z plus 1. Okay. Now if I do del z del x, so let me do it here. Let me do it here. Then del z del x, then it will be root under 4 minus x square minus y square, will be half, will be minus 2x. Similarly, so the 2 will cancel. Del z del y will be half minus 2y will be 4 minus x square minus y square. So then this ds will be root under x square divided by 4 minus x square minus y square plus y square divided by 4 minus x square minus y square plus 1 k times dA. So dA in Cartesian coordinate again the similar way, like dA, okay, let me do the summation first. So it will be 4 divided by 4 minus x square plus y square, okay. So dA in Cartesian coordinate will be dx dy, there is a dA multiplied. In Cartesian coordinate it will be dx dy. But if so, I can see this, we can see that here the x square and x square plus y square terms, these kind of terms are coming, okay. So that means we should better change our coordinate to a plane polar coordinate in this xy plane. So in that case, if I take, so this integration is we will be doing in the xy plane, okay. Let me call this rho, and this angle as psi. So then how the area element will look like in this plane polar coordinate? It will be rho d psi, and this we will replace with rho square. And we will be integrating, so we will be integrating throughout this region, okay. The entire region we will be integrating. So that means our rho will be going from 0 to up to this point, up to this radius, so that is 2, okay. The radius of this sphere is 2, so rho will be going from 0 to 2, this is 2, and psi will be going from 0 to 2 pi. So s is integration of ds, which is rho will be going from 0 to 2 and psi will be going from 0 to 2 pi. This, so root under 4 I can write it as 2 and put it outside, then it will be root under 4 minus rho square rho d psi, okay. Psi integration I can do separately, then it will be 2 pi, so it will be 4 pi outside, and this part, so this is rho d rho, and rho d rho I can write it as d of 4 minus rho square times minus half. This whole term is rho d rho. So 0 to 2, 1 by root under 4 minus rho square. Okay. So take the minus of outside, it will be minus 2 pi, and it will be 4 minus rho square to the power half divided by half, and rho will be going from 0 to 2. So then it will be minus 4 pi again, the 2 will get multiplied by this 2, and so if I put the upper limit, it will be 0 because 4 minus 2 square, and if I put the lower limit, minus sign, and this will be 4 to the power half, that is 2. So again it will be 8 pi. So basically one can integrate, what I am trying to say is one can integrate in the curved plane also, and one can also project this integration. Yeah, so one can also project this integration in this plane, xy plane, and the projection will look like this. So this is the multiplication factor we need to add, and then integrate in the xy plane also. Okay. The next one is find the area of the surface x square minus 2y minus 2z equals to 0 that lies above the triangle bounded by the lines x equals to 2, y equals to 0, and y equals to 3x in the xy plane. So here we don't have have this kind of parametric like form of this surface through which we can integrate basically. So here this kind of methods will be applicable, like the projecting on the xy plane. So let me first draw it. This surface, it's a complicated surface, so I will not draw this exactly, but let me draw this region. Okay, this region. X, y, and z. Okay, so the region is x equals to 2 line is, so this will be the x equals to 2 line, extend it. This will be the x equals to 2 line, x equals to 2, y equals to 0, this is the y equals to 0 line, that is x axis, and y equals to 3x. So this 3x will cut the x equals to 2 line at 6, y equals to 6. So let me call it this. Let me say this is the point that 2, 6. So it will look like this. So this will be the y equals to 3x line. This will be y equals to, what is that? This is y equals to 3x line. Okay. So all these three lines, the area bounded by these three lines is this area, and this plane, this surface, sorry, this is the plane, and this surface, this is some kind of complicated curved surface because it's not a linear equation in x, y, z. So this will be lying somewhere here. Let's for example like something like this. Okay, and so this, and if I look throughout upward from this triangle, then it will cut this at it will cut some region from this curved surface, and this will be a curved region. Okay, so we are asked to find out the area of this curved region. Okay, so here this is the area we have to find out, and this will be some complicated curved region. So obviously we will not integrate on that curved surface here. We will not integrate here. So what we will do is we will project this integration in this xy plane. And how we will be doing that? That is basically, so for example, let's say there is a small area element here, let me call it ds, and just beneath that, so if I do the projection, or you can assume like if there is a sun and it is, so if along the shadow of this part in this xy plane, so it will be, for example, look like this. This is the projection. So let me call it by dA. Okay, dA is basically nothing but dx dy, which is basically dx dy. Okay, so how this ds and this dA will be related? They will be related by this ds will be related by some factor times dA, and what is the factor? That is del z del x mod square plus del z del y mod square plus 1. Okay, and this z is the, so this z is the coordinate of this plane, of this not plane, of this of this curved region. Okay, so z is, from this equation I can write it as z is 2z will be x square minus 2y, then z will be half of x square minus y. Okay, so in that case del z del x is just x, and del z del y is minus 1. So then this ds will be x square plus 1, because there is mod square there, plus 1 is d. So then it will be x square plus 2. And so let me replace this dA by dx dy, because here we don't have the advantage of going through a plane polar coordinate. So let's stick to this Cartesian coordinate. So then, so this is the ds here, and what we will do is we will, to find the total area, to find this entire area, we will just add this ds, that means we will do the integration ds, which will be integration root under x square plus 2 dx dy, sorry, dx dy. And let me put the limit, so that, so here now we are integrating in this triangular region, inside this triangular region. So how should we put the limits? Let me do the integration of y first, because x integration looks complicated. Okay, so let me put y first. So first I will put the y limit. Okay, so how we will put the y limit then? So for a certain value of point xy, so in this area element, first what we will do is we will move along y axis. So that means how y limit will be moving. So this is the y equals to 0 line, so it will be moving from this y equals to 0, or any point xy, it will be moving from y equals to 0 to this line. Okay, so y equals to 3x, so the y limit will be moving from y equals to 0 to 3x. So depending on, now look at this limit, so depending on x position, so the upper point, the 3x, that will be changing from 0 to 6. Okay, so basically as x will be moving, so this region, this green region, this region, its length will vary. So if I move now with this region, if I move along x from 0 to, what is this point, x equals to 2, so then basically we will cover the entire region in this triangular plane. Okay, so the x limit will be, so while y is moving from 0 to 3x, x will be moving from 0 to 2. Now if I do the y integration, then x equals to 0 to 2, y integration is as dy, there is no y dependence here, so it will be y, and the limit is from 0 to 3x, that is, so that means it is only 3x, put under x square plus 2 dx. Okay, so I'll put the 3 outside, put this integration x equals to 0 to 2, that is x square plus 2. Okay, and this x dx, so this x and dx, I can write it as d of x square, okay, plus 2, and if I multiply by half, so then this will give me x dx. So instead of x dx, I'm writing this. Why this? Because to match with this term. So there will be 3 by 2, x equals to 0 to 2, put under x square plus 2, d of x square plus 2, and then it will be a simple integration, that is x square plus 2 to the power 3 by 2 divided by 3 by 2 and x equals to 0 to 2. 3 by 2 3 by 2 cancels, and if I put the upper limit it will be 4, x square is 4 plus 2 6, 6 to the power 3 by 2 minus if we put the lower limit it will be 2 to the power 3 by 2, and 6 to the power 3 by 2 is nothing but 6 root 6 and 2 to the 3 by 2 is nothing but 2 root 2. So this is the area of this curved surface. Okay, 6 root 6 minus 2 root 2. So what we are doing here is we are not integrating in this curved region. We are projecting this integration somehow in this plane, xy plane, and then we are integrating. And how this projection is done, that is by multiplying with this factor. Okay, so another similar problem. Find the area of the portion of the paraboloid x equals to 4 minus y square minus z square that lies above this ring, and this ring is 1 less than equals to x square plus z, y square plus z square less than equals to 4 in the yz plane. Okay, so let me draw it. Let me choose the draw the coordinates in a different way. Okay, let me put x-axis above because there is a symmetry in the yz. So if I look at the equation of this parabola, there is a symmetry in the yz axis, and for that, if I xy, if I do the cross product of xy, so this xy will be z, right? So if I do the cross product, if I curl my fingers of this right hand from x to y, then the thumb direction will give me the direction of z. So right-handed coordinate system. So then if x is upward, then the yz should be directed along this line. So y in the right-handed coordinate system, y cannot be this one and z cannot be this one. Okay, this is wrong. The cross product will be violated. What was that? Yz. So then let's draw this parabola. Okay, so when yz equals to 0, it will cut the, so where it will cut the x-axis. So when yz equals to 0, that means it will cut the x-axis at x equals to 4. Okay, and now it will be paraboloid, means if I draw it in the xz plane, it will look like a parabola. So it will be falling like this, and basically it has a three-dimensional shape, so it is not exactly a parabola, it is a parabola, so there will be circular 3-dimension portion also. Okay, so this is the parabola will look like. And now we are asked to find out, so this parabola will be lying above this ring. Okay, and the ring is, so this circle is, this equation of this paraboloid is x equals to 4 minus y square minus z square. Then equation of this circle which cuts, so this is the cutting curve of this xz plane, sorry, of this yz plane and this paraboloid. This is basically when x equals to 0, so that means this is a circle of y square plus z square equals to 4, right? So it's a circle of radius 2. Okay, and this ring, So this ring, it is bounded by this y square plus z square should be less than 4 and y square plus z square should be greater than 1. So that means this ring is basically, if this is a this is xy square plus z square equals to 1, this is a ring, this is a circle of radius 1. So in that case this ring will be this. This is the ring here they have talked about in the question, and now we are asked to find out the area of this paraboloid that will be above the ring. Okay, so if I draw perpendicular, so then basically it will cut the paraboloid. This ring will cut the paraboloid in this section, and the area we are asked to find out, that is, draw this green portion. If any point you are not understanding, then please let me know. I will write in the comment section or ask by unmuting. Okay, so this is the ring, and we are asked to find out the area above the ring that will be on the paraboloid. So we are asked to find out this region, the area of this region. Okay, but obviously we will not be integrating in the curved surface, in this curved surface. So we will be looking for some method that will through which we can integrate in this ring, basically, that is in the xz plane. Put another notation for this ring thing. The picture should be clear. If the picture is not clear, please let me know. This is the x, y and z. Okay. So now let me consider a small surface element here. Let me call it ds, and corresponding to that, let me consider surface element in this xz plane. Let me call it dA, which is nothing but dy dz, if I consider Cartesian coordinate. But we can see that there is a circular symmetry here, right? So we will be eventually moving towards a plane polar coordinate in this xz plane. So the integration region we have, that is the ring. Basically this is the ring we have. So how this ds will be related to dA? This ds, how it will be related to dA? Through, so here this z-axis is, so where there was z-axis in these problems, right? So here the same thing is happening with the x-axis. So then it will be x. So the equation of this paraboloid is given by x equals to 4 minus y square minus z square. 4 minus y square minus z square. So this is the equation of the paraboloid. So then this connection will be del x del y mod square plus del x del z mod square plus 1. Okay. So if one get a area element dA in this xz plane and multiply with this factor, you will get the area element in this curved surface. Let me find out del x del y. del x del y will be minus 2y, and del x del z will be minus 2z. So if I do the mod square, it will be 4y square plus 4z square plus 1 dA. Okay, is the ds. So now, as I was saying, let me draw the now where so this dA is dx, dy dz. This dA is this dy dz. We are in the yz plane here, projecting it in the yz plane. So let me draw this yz plane. And we'll be integrating here. We'll be integrating here. So this is the radius 1 circle, and this is the radius 2 circle. So obviously it's good to choose a plane polar coordinate. So let me choose it by this axis rho. Let me call it the distance from the center as rho, and this angle as psi. Okay. So in that case, this dA we can write it in this. dA will be in this plane polar coordinate. It will be rho d psi. Okay, and this, if I take this 4 common, and it will be y square plus z square, that is basically rho square plus 1 times rho d psi. Okay, so s will be then double integration of ds, which will be double integration of root under 4 rho square plus 1, root under 4 rho square plus 1 rho d psi, rho d psi, and rho will be going from, so we'll be covering this area, so rho will be going from 1 to 2, so we are now in the xy plane, yz plane, and psi will be going from 0 to 2 pi. That will basically cover the entire ring. Now if I can integrate psi separately the same way, like it is 2 pi, psi integration is 2 pi, and then the rho integration, rho will be going from 1 to 2, 4 rho square plus 1, and this rho d rho I can write it as d of 4 rho square plus 1 times 1 by 8. So if I do d of 4 rho square plus 1, I will get 8 rho, and by 1 by 8, so it will give me rho d rho. I can put 1 by 8 outside, then it will be pi by 4, and if I do the rho integration now, it will be 4 rho square plus 1 whole to the power 3 by 2 divided by 3 by 2, and rho will be going from 1 to 2. So 3 by 2 is 2, and 4 cancels, and 2 and 3 will multiply by 2, and that will be 5 by 6. And if I put the upper limit, it will be 4 times 2 square, that is 4 times 4, 60, plus 1, 17, 17 to the power 3 by 2, minus if I put the lower limit, it will be 4 plus 1, that is 5, so 5 to the power 3 by 2. So pi by 6 times this is 17 to the 3 by 2 can be written as 17 times root 17, minus this is written as 5 times root 5. So the correct answer is the first one. Okay. So basically throughout all these problems we have used the same idea, like we don't want to integrate in the curved region, we want to integrate in the curved surface, we want to integrate in the plane surface. This is how we'll project. Integrate the function over the surface of a unit sphere. The function is f of x y z equals to x square, just function of x, and the sphere is a sphere of radius 1 having the origin as center. X square plus y square plus z square equals to 1. So this is the sphere, x, y, z. Okay, this is sphere of radius 1. So let me parameterize it in using the spherical coordinate. So if this is the radius r, which is 1, let me define the theta angle as this, and if I do a projection along this xy plane, that phi angle is given by this. Okay, so the length of this projection is nothing but r sine theta. Okay, and this length is nothing but r cos theta. Okay, so this angle is theta and this is r, so this will be r cos theta. This r cos theta, you can see it is nothing but the z axis, the z coordinate of this point, z coordinates of this point, and the x coordinate will be then, so then the x component will be, so this is r sine theta, and if I take the projection on the x axis, it will be r sine theta cos phi. It will be r sine theta cos phi. Y will be r sine theta sin phi, and z will be r cos theta. Okay, and this r is 1, so let me remove this r. This r is 1. So for this particular problem, this will be the xyz. While we are moving on the surface of the sphere, if we want to get inside or outside, then we need to put the r and vary that. The integration function is x square. So the surface. So I will integrate on the sphere. I will not make it long. Okay. So this ds. This ds is nothing but r square sine theta d theta d phi, and r square is 1. So this is r is 1. So this is the ds. Okay. And we are asked to integrate this function over the surface. So the integration what we are asked to do is I, which is this f of xyz times the surface. Okay, and this f of xyz is x square, so do it x square ds. So ds we are putting in spherical coordinate, so we should also replace our x by the spherical coordinate, and x is sine theta cos phi. So let me replace x as sine square theta cos square phi, right, and ds is sine theta d theta d phi. So this is sine square theta, and theta will be going from x is sine theta cos phi, sine square theta cos phi. Okay, theta will be going from 0 to pi, and phi will be going from 0 to 2 pi. Okay, this is because we want to move on the sphere, so theta limit should be going from 0 to pi. Otherwise, if theta is going from 0 to 2 pi, then it will be we will covering it twice. And let's go to the integration. Phi equals to 0 to 2 pi. Cos square phi, I can take it here. Cos square phi. It will be theta equals to 0 to pi. It will be sine cube theta d theta, and this is d phi. So how to do integration of sine cube theta? Let me do this integration first. Integration of sine cube theta. Integration separately, like sine cube theta d theta. So one can directly use the sine 3 theta formula, but let me do it like this. So this sine square theta sine theta d theta, then it will be half sorry, then it will be 1 minus cos square theta sine theta d theta. So it will be integration of sine theta d theta minus cos square theta sine theta d theta, that I can write as sine of minus cos theta, sorry, d of minus cos theta. This minus I can put outside, then it will be plus. So it will basically minus cos theta plus cos cube theta by 3. Okay, and if I put the limit, so theta equals to 0 to pi, that was the limit of theta we had. So theta is 0 to pi, 0 to pi, theta will be going from 0 to pi. This minus cos theta, if I put pi, it will be plus 1, minus, so it will be plus 1. And the second term, it will be minus 1 by 3, minus 1 by 3. Right, so it will be 2 plus 2 minus 2 by 3. So it will be 4 by 3. Let me know if I'm doing some mistake. And this phi integration, that I can do separately also. 0 to 2 pi cos square phi d phi. I can put a half here, 2 here. So in that case, it's half, then 0 to 2 pi. 2 cos square phi can be written as cos of 2 phi minus 1 d phi, and d phi to the integration, then it will be half 0 to 2 pi. This will be sine of 2 phi by 2 minus phi. Sorry, integration is done. So it will be 0 to 2 pi. No, minus sign. Okay, this is plus. But in the positive quantity, integration should not be minus. It's plus. Because this cos square 2 pi is cos 2 pi is cos square phi plus, sorry, minus sine square phi, and this 1 can be replaced as cos square phi plus sine square phi. we will get 2 cos square phi. So if I put this limits on this term, it will give me 0. If I put limit on this term, it will give me pi. There is a half here. So what we get is, so this integration is pi, this integration is 4 by 3. So it will be 4 pi by 3. Okay, it's 4 pi by 3. Second option. We're already running late. So find out the surface integral of this vector field f equals to z k cap across the portion of the sphere in the first octant. Okay, this is a sphere of radius a having origin at the center, and the direction is away from the origin. Okay, let me draw the sphere first. It's x, y, z. This is the sphere of radius a. So x square plus y square plus z square equals to a square. So surface integral will be like f dot ds integration. So how the ds will be, so if small surface element, and if n cap is the unit vector directed perpendicularly outward from the surface, so then this ds is the mode of ds, let's say, and ds vector will be n cap ds. Okay, so then what we have is basically f dot n cap ds. So I will not project it any further. I will do the integration in this curved surface, in this spherical surface. So this ds in the spherical surface is so this is a surface of radius a, so that means it will be a square sine theta d theta d phi. Okay, this is the surface element on this sphere, and let me find out this f is given by this vector. F is basically z k cap. Okay, so now we need to find out this n cap. Okay, that's what we need to find out. And if we want to do the integration in the spherical coordinate, then we need to replace this z by the spherical coordinates parameters. Okay, so that's the two things we need to do, and then we can do the integration. Okay, so let me write down the xyz then. So x will be then radius a sine theta cos phi. Okay, the same convention I'm following. So the convention I followed here for theta phi. So theta is this angle, phi is this angle, and a is the radius. So I'm following the same convention. Y is a sine theta sine phi, and z is a cos phi. Okay, then the r vector will be a, sorry, let me write it as r. Okay, why I will mention. So r sine theta cos phi I cap plus r sine theta sine phi j cap plus r cos phi k cap. Okay, so this is the radius vector, So if we are on this plane, then r is a, then it is a constant. But if you want to look outside from the, if you want to go outside from the plane or inside, then r is a variable. So how do we find out this n cap vector? This is the radially outward vector from the from the from the from this spherical surface. Okay, so this any radially outward vector n hat, which is radially outward vector, so it is unit vector. Okay, is given by del r divided by, this will give a vector, and divided by the magnitude of that. So this del r vector by del r is basically we are changing the radius and we are seeing a change. So that the change will only be in the outward radial direction. This is a vector in the radial direction basically. Del r vector by del r, and if we divide it by magnitude, its magnitude, we will get the unit. We will get the unit vector. And if you do that, you will, what you will get is nothing but sine theta cos phi I cap plus sine theta sine phi j cap plus cos theta, sorry, this is cos theta, this z is cos theta, cos theta k cap. Okay, and then now we are done basically. So then this f dot n hat, it will be f dot n hat, it will be, so f I can replace is z k cap, and z I can replace at a cos theta k cap dot with this nr, right? So only k component will survive, then it will be a cos square theta. Easily see, only this component will be contributing, this component, k component. So this integration will be then f dot ds, which will be f dot n hat ds, it will be f dot n hat is a cos square theta, we have just calculated, is a cos square theta, and this ds, this is radius square, that is a square sine theta d theta d phi, a square sine theta d theta d phi. Okay, and theta will be going from 0 to pi, phi will be going from 0 to 2 pi. Okay, let me know if these limits are clear. I mean, if not, then please let me know that why phi is going from 0 to pi and theta is going from 0 to 2 pi. Why theta is not going from 0 to 2 pi. So a cube, then if I do the phi integration separately, then it will give me 2 pi, and this is cos square theta, and d sine theta d theta I can write as a d cos theta with a minus sign, so minus sign I'm putting it here, and then theta is going from 0 to pi, is minus 2 pi a cube, it will be cos cube theta by 3, theta equals to 0 to pi, this is minus 2 by 3 pi a cube. If I put the upper limit, it will be minus 1, minus of, if I put the lower limit, it will be 1, so there is a minus sign here also, so it will be minus 1, so then it is minus 2 multiplied with this minus sign, so it will be 4 by 3 pi a cube. So okay, integration is not matching. Okay. We are asked to integrate in the first octant, okay, in the first octant. So the limit I need to choose carefully. So if we want to be in the first octant, is x, y, and z. So in that case, if this is a radius vector, okay, this is the radius vector. So then this is theta, and this projection angle is this theta, and this projection angle is phi. So then theta will be going from 0 to pi by 2. So that will be, so if theta is pi by 2, then we will come at this xy plane, and that's it. Okay, and phi will be going from 0, so while we are on the xz plane, to again pi by 2. So that will move to the yz plane, and on that way we will stay on this first octant. Okay, so the phi limit, theta limit also be from 0 to pi by 2, phi limit will also be from 0 to pi by 2. So this is where I made the mistake. This limit is pi by 2, this limit is pi by 2, because we need to stay in the first octant. This limit is pi by 2, so this is not 2 pi, then this is pi by 2. So this is, sorry, this is pi by 2, this is pi by 2. So this is 6, so this is 6, 1 by 6, because 3 here and there is 2 here, and this is minus 2. It's not minus 2 because the limit will change. So if we put the upper limit, cos of pi by 2 is 0, so the upper limit will be 0 and lower limit is minus 1. If we put the lower limit, it will be minus 1. So it will be, then there is only minus 1, this time is minus 1, then it will be pi a cube by 6. Okay, so this is the integration. So this will be the correct option, last one. Now the next problem, evaluate the integral or the circle is this. Okay, so let me draw the circular region first. So we are at point x equals to 2, y equals to 3. Let me say this is 2, 3. So then the region will be, in the circle will be look, circle has a radius of 2. So circular region will look like this. Okay, so this is x minus 2, so this center is 2, 3, and this radius is 2. X minus 2 square plus y minus 3 square equals to 2 square, the x and y coordinate. This radius is 2. Okay, and we are asked to evaluate this line integral along this curve, this closed curve. Okay, so I have to find out this line integral along this closed curve, and let me call it p of xy dx. So basically the idea is, this is a kind of complicated curve to track, so what we'll do is we'll use the Green's theorem and transfer it to a surface integral, this line integral to a surface integral. And q of xy dy, so if c, this p is nothing but this. Okay, So if I compare these two, then our P of xy is nothing but, so this is the integral I. So P of xy is nothing but 6y plus x, 6y plus x, and Q of xy is nothing but y plus 2x. Okay. So I am writing like P and in this form of P and Q because we want to convert it in the, we want to use the Green's theorem and convert it to the surface integral. So the Green's theorem says that I is P dx plus Q dy, this line integral, it will be surface integral. The surface will be the surface that is enclosed by this closed region, and it will be del q del x minus del p del y dx dy. Okay, and the surface enclosed by this region is this surface, this circular disc, and this del q del x, so del q del x is 2. Okay, so if I do the del q del x here, del q del x is 2, and del p del y is 6. Okay, so let me check whether I wrote the Green's theorem correct or not. Yeah, Green's theorem is correct. So del q del x is 2, and minus del p del y is 6, so it is minus 6 dy dx. So it will be then minus 4 double integral dy dx. Now this dy dx, this is basically the dA, this is the surface element on this sphere, this is the dy dx, and we are asked to integrate in this region. So what will it give? This will give the entire area of this sphere. Okay, so dA is the small area element, or we are adding all this area element while being in the boundary of this circle, so that will give me the area of this circle. So then it will be minus 4, and area of this circle has a radius 2, so it will be pi 2 square, pi times 2 square, so it will be minus, so this is 4, so 4 times 4 is 16, so minus 16 pi. So correct option is minus 16 pi. Okay, we're asked to find out the area of this region enclosed by this circle. Okay, this is very easy. So circle is, I will not I will do it very simply, like, so this x is 3 cos t and y is 3 sin t, so which is basically r cos theta and r sin theta. Basically, theta is equivalent to t, and t will be going from 0 to 2 pi, so you can just easily do it, like, so it is basically a circle of radius 3, circle of radius 3, so the area will be 9 pi. Simple, like a equals to pi 3 square. Okay, area will be 9 pi. Here you can do the integrations, like considering x and y. Now you can parameterize them, and parameters are given, so you can convert it to the plane polar coordinate also, and do the integration. Okay, so problem 9 is find the equation for the tangent plane to the surface of the cone. This cone is given by this: x is r cos theta, y is r sin theta, and z is r. Theta r is greater than 0, and theta will be going from 0 to 2 pi. And the point where we are asked to find out the tangent plane, that is root 2, and which will be corresponding to a r theta coordinate. If we transfer it to r theta coordinate, the r will correspond to 2 and theta will be corresponding to pi by 4, that is given. Okay, so first let me draw the cone. Okay. So x, y, z. X equals to r cos theta, x coordinate is r cos theta, y coordinate is r sin theta, z coordinate is r. So basically its equation will be z square equals to x square plus y square. So what this means, that it means that as z increases, this x square plus y square, it will increase. So basically this will how the cone will look like. Okay, and now we're asked to find out. So let's say this is the point where we are asked to find out the tangent plane, equation of the tangent plane, right? So what we need to do is we need to find a vector. We need to find a vector that will be perpendicular at this point, perpendicular to this cone at this point. So that means it will be perpendicular to the tangent plane also. So if this is a tangent plane, for example, this is a tangent plane, so then it will be perpendicular to the tangent plane. So first we need to find out this vector, n vector. Okay, and then what we will do is we will consider any point on this plane. So let me any point we'll consider, example x, y, z. Okay, and this point we know, so where we are asked to find out the tangent plane, that is the p0 point, which is, this point is the p0 point, that is root 2 2. Okay, so then a vector, if I draw like this, if a vector I draw like this on the plane from this p0 point to any point on the plane, on this tangent plane xyz, so then this vector is given by nothing but x minus root 2 I cap plus y minus root 2 j cap plus z minus 2. Okay, so this is the vector. For example, let me call it, what should I call it? Let me call it p vector. So then the equation of this is the p vector. Then the equation of this plane, tangent plane, will be, so we need to find a condition, right? The condition is basically this n vector is perpendicular, will always be perpendicular to the p vector because it's a tangent plane. Okay, so then the equation of this plane will be p dot n cap, or any n vector. We don't need to find out the unit vector also. We just need to find out any vector which is perpendicular at this point. So p dot n equals to 0. This will be the equation of the tangent plane at P0. Okay, so first what we need to do, so we already know what is the P vector, so we need to find out this n vector that is perpendicular to this tangent plane at point P0. Okay, and that how we will do is R is given, let me call it phi also. So we'll follow the same method. I mean that is followed in the class, in the lecture videos. This is phi. Phi is R cos theta, R sin theta, R cos theta I cap plus R sin theta j cap plus R k cap, right? So this is basically R. This is at any point. This will be any point on the cone, and let me write phi R, which is del phi, del R. Okay, so this is if I change, so this is a vector which will be directed along this along this phi x. I'm sorry, along this R parameter change. So the direction the R parameter is changing, this vector is directed at that direction. This is the P0 point. This del phi del R is cos theta I hat plus sin theta j hat plus k hat, and phi theta. So basically this will be the phi R, and phi theta is del phi del theta, which will be R, there will be minus sign, R sin theta I cap plus R cos theta. Okay, so phi is changing along this direction, so that means, so this, it will be directed like this phi theta. So any vector, if you want to find out that is perpendicular, so a vector if you want to find out that is perpendicular to this tangent plane, so this phi theta and phi r, they will be lying on the tangent plane. Okay, so these are kind of the tangents in different directions, so they will obviously be lying on the tangent plane. And this n cap, this n vector, which is a perpendicular vector from this tangent plane, that will be nothing but phi r cross phi theta. Okay, or this phi r, if we do the phi r cross phi theta, so then we will get a vector that will be directed inward. But if you want to get a vector that is directed outward, what we need to do is phi theta cross what of phi r. Okay, both will work because we only work at vector which is perpendicularly directed. Doesn't matter whether it is inward or outward. So I j k, and phi theta is, so I can put this r outside, so it will be minus sin theta cos theta 0, right? Yes, and this will be cos theta, and this will be cos theta sin theta 1. Okay, this r is there, and If I do the find out the determinant, it will be I cap cos theta plus j cap sin theta, j cap sin theta plus k cap minus sin square theta minus cos square theta. So which will be r cos theta I cap plus sin theta j cap minus k cap. Okay, now at this point theta is pi by 4 and r is 2, so this n vector will be 2 times cos theta. So cos theta is theta is pi by 4, so cos theta will be 1 by root 2 plus sin theta will be 1 by root 2 minus 1. This n vector will be root 2 I hat plus
minus k vector.
Yeah, thanks. Minus k vector minus 2 k. Okay, so now what we will do is we got this n vector that is perpendicular to this tangent plane, and this p vector is depending on x, y, z. It will be some vector on the tangent plane, and this n is perpendicular to the tangent plane, so we'll do the dot product and make it 0, and that in that way we will get the equation of this plane. So if I do the dot product, the p vector dot n vector will be 0. Okay, now this p vector is x minus root 2. X component of this p is x minus root 2, x minus root 2, and x component of p is root 2 plus x component of n is root 2, and y component of p is y minus root 2. So y minus root 2, y component of n is root 2 plus z component of p is z minus, sorry, this k vector will be outside, the z minus 2, so it will be z minus 2 and z component of n is minus 2, so let me make it minus 2 equals to 0, and if I do the further calculation, it will be root 2x minus 2 plus root 2y minus 2 minus 2z minus 4 plus 4 equals to 0, and now this minus 2 and plus 4 will cancel, so we are left with root 2x plus root 2y minus 2z equals to 0, and I can divide by root 2, then it will be x plus y plus minus root 2z equals to 0. This will be the equation of the tangent plane. Third option. Now the last problem is, because f is given by this and this is the f dot ds which is given by this, so somehow this ds is defined in some way. Okay, so f dot ds is defined by this, continuous having continuous fast particle in the region containing r, then this equals to this, where simply closed curve. So we're asked to find out whether this statement is true or not. Okay, so our integration is, let I is Cm dy minus n dx. Okay, now if I C minus n dx plus m dy, and I can write this n as I can write this m as p, and this m minus n as p and m as q. So p is minus n, q is n. So then this I is integration c p dx plus q dy. Now we want to, so we need to match, so we need to check that whether if we transfer it, this line integral, to the surface integral, whether this equation is valid or not. So if you want to transfer it in the surface integral, we need to apply the Green's theorem, and it says basically del q del x minus del p del y del x del y dx dy. Okay, and del q del x is nothing but q is n, so del n del x, and del p del y is, there is a minus sign, to be plus, sorry, q is m, and del p del y, p is minus n, so it will be plus del n del y dy dx. Okay, so if we convert this line integral to surface integral, this is how it will look like. There will be plus sign, but there is a minus sign, so this statement will be false. So these were the 10 problems from assignment 7 of last year's course, and someone asked in the beginning to explain the limits. Yes.
So,
Yes, tell.
the previous problem, you have written phi r cross phi theta cross phi r.
Yes,
Okay, that determinant you have found, right?
yes, the determinant is the cross product basically.
Yeah.
Hmm.
In case if I write it as phi r cross phi theta,
Hmm.
is there any flaw?
No, there is no problem. So here what I'm doing is, I have in the figure, in the picture, I define this n vector as outward, directed outward vector, right? This n vector is directed outward. So if we do the phi theta cross phi r, if we just curl your fingers on your of your right hand from phi r to phi theta to phi r, so then you will get your thumb will be directed outward.
Yeah.
So then you will get a normal vector which will be directed outward. And if you do the phi r cross phi theta, you will get a normal vector which will be directed inward. So in that case, if you do that, will be directed inward. But both will be perpendicular to this plane. Okay. So
both will be perpendicular.
Both will be perpendicular. So when you do the dot product, this is valid because this dot product.
That's okay. That I understood.
Yes.
Only the previous, because I have worked out the problem.
Yes.
Making phi r cross phi theta, but I didn't get the solution. That's because the constants doesn't cancel. Okay, that's what I got in my working.
But
so
what did you find as the n vector? Because the n vector will then be a minus sign only multiplied by this term, nothing more actually.
Nothing will be there.
And this minus sign, I mean, as the right hand side is 0, then this minus sign doesn't matter. So
right. Thank you.
Yeah, so you can check your calculations. The final equation will not change. I mean, maybe you will get something like minus x minus y plus root 2z equals to 0. Okay, this kind of equation, but this is same as this equation, just a minus sign multiplied.
Thank you.
Yeah. Okay, so sixth week first question. So sixth week first question of last year's course or this year's course? That you have not mentioned. Let me check.
This year's course, sir.
This year's course, okay. Find the center of mass and the moment of inertia of a thin triangular plane plate bounded by the lines y equals to x, y equals to minus x, and y equals to 1. Okay, so the boundaries are
Not this question, sir. Actually, a recent question, sir. Find the center of mass movement x-axis triangular plane y equal to x, y equal to minus x, y equal to 1.
yeah, I found that out. So y equals to x. So I just need to explain the limits, right?
Yes, sir. Only
Okay.
limits.
Y equals to x, y equals to x, y equals to minus x, and y equals to 1. So y equals to x, this one, y equals to minus is this one, and this is y equals to x, y equals to minus x, this is y equals to 1. Okay, so this, I mean, the integration will be something there, and so this surface element d is nothing but dx dy. Okay, so it will be good because if I do the y integration first, so in that case there will be two limits, like uh, in this region y will be going from minus x to y equals to 1, right? And in this region y will be going from plus x to 1, right? This is the plus x, y equals to plus x to 1. So we need to divide the integration while we will be doing the y integration, we will be dividing it by two parts. But if you don't want to do that, so then you can do the x integration first. Like if I do the x integration first, so then this is the x integration. So we will we take a small surface element dA and we will add them up along the x-axis, along its x-axis. So if I do the x integration first, so then the x limit will be, so if I do the x integration first, and dx dy, so then the x limit will be, so the x limit will be going from this line, so this line, from this line to this line. Okay, this is how the x limit will be going from. So x limit will be going from minus y to y,
Y to plus 1.
minus y to y. So x will be going from minus y to plus y. and now while you will do the y integration, so you will move this line along this y axis. So this y limit will be going from 0 to 1. So y limit will be going from 0 to 1. Okay, so this is how you can do it if you do the x integration first. But if you want to do the y integration first, then you need to divide it into two parts. Okay, any other question? Yeah, thanks everyone for joining.
Thank you, sir.
Okay, if not, then I'm ending the class then.